It's nice being here. We've been into contact with the Epoch team, actually the predecessors, for a while. And I'm very happy that they approached us, I think, half a year ago to look at an appropriate challenge for today. And there was a bit of back and forth, but in the end, we ended up on the one which has been touched upon today, so that the birds, radars, and wind farms. And I'm here to give you a bit of introduction also to where the data is actually coming from. So in this picture, I'll get back to it. So that's the radar over there. But to give you a bit of content, so I'll start a bit with an introduction of TNO. You might not be aware of what kind of organization TNO is. Then I'll give you a bit of introduction to the Black Blade project. So that's where we actually gathered the data. A bit on bird monitoring, different mitigation techniques, some hints, right? Because you were working with the data and you'll not only get the radar data, but there might be some other sources. So I'll give you some hints where you could look at who is who. Already introduced my colleague Eric over there in the corner. And we also want to present a vacancy. So we're looking for a student actually for an internship, and I'll get back to that. Then TNO. TNO is a very big organization, so it's independent, actually founded in 1932, so quite a while ago. And there's a law in the Netherlands which states there should be an organization like TNO. And we work in a very wide, big field, so energy and transition material, that's the one I'm working at. A lot of defense stuff. Actually, most of our radar experts are on that one. A healthy living, high-tech industry, built environment, where we also use some models. I'll get back to that. And of course, ICT strategy and policy. So that's where a lot of our AI work is there. Then this opens up slowly. So I think what's important is TNO is in the center here. So we work together with knowledge partners like universities. We have sort of public partners, so would be the government, and then we have industry. And we try to bring this all together. Some numbers of last year, but we have quite a lot of people. I think also a nice mix. It's a Dutch institute, so it's relatively Dutch, but we have some also a lot of nationalities. Actually, in our department, it's more. I'll get to that. And also, well, it's still technical, but a relatively healthy male-female distribution. We're all over the Netherlands. There's a big concentration, sort of Rijswijk, De Heek, Delft. I think even in Delft we have sort of 5 addresses where TNO is. Actually, one of them is next to here. But we're all around the Netherlands with also specific labs for specific technologies. Then the wind energy team, so that's the one I'm representing. We're in 2 locations, one Pette, really cool, next to the beach, and Rijswijk, not so cool, but close. And 55 people, so there we see a bit more international colleagues. Eric is actually from Germany. And we're working in different fields. And ecology is one of them. So now I'll get to the actual case. So you saw this picture before. Now I've highlighted it. This is where the radar is. And we did this because we want to include one of the mitigation strategies. So you see this turbine over here has a black blade. And the idea was that if you paint the blade black, it's more visible for the birds, and we have less birds crashing into the turbines. So that's why we gathered the data. Just to show you where this is, well, this is really at the top of the Netherlands, Eemshaven, Groningen. There's a big harbor here, big industry area. We have the max location here, next to this turbine. So this is providing electricity and we looked at those 4 turbines. And then sort of mostly turbine 21 and turbine 20. Like mentioned before, we did this with this specialized bird radar, of robin radar, also a spin-off of TNO. And we did this with 2 different radars. First, we deployed the radar of Waardenburg. And then for the first period, and then the second period, we did this with our own radar of TNO. They're actually the same type of radar, so the top piece is the same. So these are the data sets you will be provided with. How does this look? And I hope the movie is playing. Maybe tick. Of course not. Yes, something is happening. So this is, you see the radars over there, and these are all kinds of objects moving, right? There's already filtering over it, and but you can already see some aspects. This is a car, for example. It drives along the road, and it's identified as a sort of a ground object. Then normally sort of yellow, orange, and red colors are birds, but the classification is not perfect. For example, here, you see these circles there and there. This is not a bird. This is a blade of a wind turbine, which is classified as a bird. But you also see some other interesting aspects. For example, this one here, this bird pattern. This is a bird, but it flies in a distinct pattern. And this is something you could use to identify the species. So we've gathered a lot of these data, and then the question is, you don't have a label. So the colors give sort of an indication of the size of the bird, but not what particular species it is. And for that, you need to have annotated data. And this we have, because we had bird experts in the field with binoculars for a couple of days, and they sort of annotated specific radar tracks. So they used the GUI of the radar to select the track, and then manually or sort of with a drop-down menu say, well, this is this species, this is this species, etc. So they did a total of 18 field visits with around 5,000 tracks validated, and you get a subset of this to train your AI models. What is important is that all this at TNO, we're not ecologists. We're pushing it from the technological side. So we're working there together with real ecologists. And so there's a report of Waardenburg ecology. I think that's that one. And it's in Dutch, but I think you can use some kind of AI to translate. But it will give you a lot of background for the challenge ahead. Well, these are some experts from that report. So these are the field visits. So they were there in a couple of days, focusing on particular turbines, starting end, some temperature difference. So this is where they actually were in the field, looking with binoculars and tagging those tracks. There's also a limit there, because you can see this was mainly during the day, not during the night. And then here you have a quick overview of all the typical birds that they saw, mostly gulls, but also some other different species. They already did some classification, looking at, again, sorry, this actually is in English. So here you see different type of birds, and you can look at differentiating sort of flight height, radar cross-section, flight speed, etc. And this is sort of a start where you could maybe distinguish between several species. For example, we see here the birds of prey. So these tend to circle, right? To make use of thermals. And you see that the directionality of the track, so the straightness of the track, is different. There's a bigger spread there. So that would be a thing to differentiate between certain species. Good, so that's more or less about the data set. Then I want to go a bit more into depth about monitoring, also to look at these different species, because I think this was explained by Bart, among others, that we need species-specific information. And historically, this is done like this. We have ornithologists in the field with binoculars, and they look. But they have their limitations, right? They cannot see when the visibility is bad, and at night they also that's limitations. So that's where sort of technology comes in. And we can do this in a big range of all kinds of far away and close. If you look to the very long range, you can make these small GPS backpacks of birds or other kinds of transmitters. And there you get very long distance information, but only from very specific individuals. Then, of course, we have radar. We can use DNA. We can use all kinds of camera techniques to get information. We can use microphones. We can sort of hear the sounds. Also there you can use a lot of AI to identify species. And sort of at the latest end, looking into when and why birds are colliding. We also have vibration sensors in the blades, which actually see this. Then also from this Black Blade project, I have some examples. So there we looked at with cameras on the ground on this particular turbine to look at the interaction of birds with the turbine. We also had some microphones placed there. And then for the videos, you get these kinds of images. And this one I particularly like because you see this bird, it's very small, but you see it sort of hesitating. It's timing its passage through the rotor blade. So I think this, and it actually speeds up when passing through. So in general, birds are not stupid. Collisions are relatively limited, but they still are an issue. And this is sort of a small, simple setup, but we also do this offshore. So then we have this big organ of cameras, and then you get these kind of videos. And that's, I think that one also is playing. So here we didn't do the filtering yet, but you see the detection algorithm is working, and you see birds flying here and here. So very small dots. But again, no identification of species, right? So you see a couple of pixels flying. Then a bit more on the vibration sensors on blades. I think that's where we detect collisions. And then we have, well, like I said, vibration sensors in the blades. You see sort of a sine wave, that's gravity going up and down with the blades. And when a bird, or in this case it's a bat, impacts, you see a very sharp peak. And this way we gather important information of actual collisions. A lot of it is actually predicted collisions based on models, but they actually want to know when and why it's happening. Mostly, originally, this is done by just working circles around the turbine, seeing whether there are casualties, but this is a much more direct way because it also gives you when and why. So what can we do to prevent this? Well, first we'll see what is the effect of wind energy on birds and bats. One, there's habitat loss. Well, if you place a wind farm in a certain area, birds, well, have limited access there. There's avoidance. So birds, like I said, they're not stupid. They tend to fly around, which maybe will cost them more energy to get somewhere, which have an effect on population size. And then, of course, then sort of the direct impact would be the collisions. And what we want to do, if we want to place a certain wind farm there, there's a certain biodiversity impact, and we have to take different measures to, in the end, maybe even have a positive effect on birds. I do have to put stuff in perspective. Sort of, we're talking a lot about sort of birds, and so you would maybe expect that wind turbines are the biggest bird killers. They're not. They're not the main cause of bird mortality. You see, there's a lot of different. This is a European plot. That's a US plot, and you see actually cats are one of the biggest problems. But, like I said, that does not mean that we do not have to do anything about it. And like Bart explained, it could be that on a general level, wind turbines are not an issue, but for certain specific species, it is. So that's why we have to look into this. And we can do a lot of stuff, right? I think sort of curtailing is already mentioned, sort of stopping the turbines. But you can also look at sort of offsetting, so reinforcing populations, make sure that they make more babies or have better circumstances to make more babies. You can look at where you position the wind turbines. This is also already mentioned by Bart. You can also look at the layout of the turbines, the size of the turbines, the shape of the turbines. And you can look at a sort of a turbine local, and then you could also even look at micro curtailment. So not stopping a complete wind farm, but there are actually systems which can detect a bird flying towards a turbine, identify it, say, well, this is a sensitive species, so we have to do something about it, predict that it's flying towards the turbine, and then stopping that turbine. And sort of at TNO, we're actively looking into this. So we're looking at modeling different sizes of turbines and the effect of birds. So that we have where to place turbines with respect to certain sensitivity areas of birds. But also, this is an interesting one. This is an agent-based model based on a traffic model. So car drivers, how they react onto traffic. And we rebuilt this to have birds react at turbines. And this is actually the one where we're looking for internship. Then some hints. One is to use other data sources. You get a particular data set, but there's more you can find. For example, weather data, right? There are two so this is the actual location. There are two KNMI weather stations there. So this is open access, very, very easy. And can you look at sort of wind speed? Because the radar will give you ground speed, but you want to calculate, well, the speed the bird is actually flying. You can look at things at sort of rain, air density, all kinds of things. Of course, then it's also important to look at bird information. There will be sort of a list of local species. We had the sound AI module running, and it identified a king penguin. So we thought, well, that's probably not, it was a very low reliability, right? Sort of 0.3 something. But sort of based on the location, we could be pretty sure there was no penguins around. So I think that's important. And also sort of activity of during the year, activity during the day. Some birds are more active during the night. Some birds are more active at the beginning of the day. Size, of course, that will give you information about the reflection of the radar, flight speeds, flight patterns, how quick they turn, how high they turn, sort of the spiraling motion I showed you before, or the birds of prey will make the circling motion. And I think that's important. So this is sort of a graph where you see sort of mean airspeed with body mass or something that could also be helpful. Yes. And I think one other thing is just a general hint. The radar time is in UTC, whereas the information in the report would be either in Central European time or even Central European summertime, because there's some data in September and there's other data in. So take that into account. And then I'm almost there. Who's who? Well, that's me. That's Eric, who's over there. And we also have Sam, who can help. You'll not directly contact us, but this will be via the Epoch team. But then you know at least who will be helping you. And I think what's also important to say, I want to thank Waardenburg Ecology, RWE, and also the province of Groningen to make part of the dataset available to you. And then I would like to end with the vacancy. Like I mentioned, we want to simulate bird flight through offshore wind farms using this agent-based modeling. You can apply now. There's a link. You can also find it on the, this is a screenshot of the TNO website. You can also find it there. And I think with that, I would like to end my presentation. Well, I made a mistake there.